Hurry up, please. Okay, 12D. We are talking about mutually exclusive and non-mutually exclusive events. Mutually exclusive means that the events have nothing in common. They have the following properties. The probability of A and B is going to be equal to 0. Mutually exclusive, there's no overlap, which means probability of A and B is equal to 0. That means if I want to find the probability of A or B, it's just the probability of A plus the probability of B. If they are non-mutually exclusive events, then there is an overlap. And to find the probability of A or B, it will be the probability of A plus the probability of B minus one lot of the overlap, because otherwise we would have counted it twice. Okay, there's only a couple of examples on this. Example number 1. In a group of 80 people, 26 people like apples, 23 people like bananas. If 7 people like both foods, what is the probability that a person chosen at random likes neither food? Okay, the easiest way, I'm going to do this question twice, okay? Because the way that I would do this, the easiest way, I'm going to do that first, but I'll do it a second way to show you using the formulas that we've been provided with there, okay? So I think the easiest way to do it is to look at your Venn diagram. If we have a group of 80 people, we have a group A and a group B. It says 26 people like apples and the B is for the bananas. So A is for apples, B is for bananas. And it says 7 people like both. So I'm going to put the 7 in there for my overlap. That means I do 26 minus 7, and there is 19 people that only like apples. If I do 23 minus 7, there are 16 people who only like bananas. I need to find out how many people there are to go outside the little box in there. So there's 80 people altogether. If you go 80 minus the 19 minus the 7 minus the 16, has anyone done it? 38. Okay, so there is 38 people, not what I asked. There are 38 people who do not like either of those fruits. So once you have the correct diagram, the probability that they like neither A or B is equal to neither A nor B means not A, not B, which does mean the one outside of those two circles, which is the 38 out of the 80, which simplifies to 19 out of 40. Okay, that is how I would do it. I think that's easier. But because we are talking about non-mutually exclusive events, let me also do that question again using that formula that has been provided up there. If I am trying to find the probability of neither A nor B, pretending that I don't have the Venn diagram, okay? So I'm pretending I'm doing this without the Venn diagram. That would be, if A or B is going to be everything that I don't want, I want to do 1 minus that. So the first thing I'm going to find is the probability of A or B, okay? To do that, I need the probability of A and I need the probability of B. From my information, there was 26 apples out of 80. So 26 out of 80 are apples. That's my probability of A. The bananas, there was 23. So 23 out of 80 are bananas. The probability, because this is a non-mutually exclusive event, I know I have an overlapping section, so I also need the probability of A and B, so I don't accidentally count that twice. It tells me in the question that A and B is the 7 people who like both, so 7 out of 80. So if I finally find probability of A or B using my formula, it's the probability of A plus the probability of B minus the probability of the overlap. and that makes the 42 out of 80. That's not the answer, because I have found A or B. I found the total of the circles. If I am really after the probability of neither A or B, that's a complementary event where I'm doing 1 minus the 42 out of 80, which will then finally give me the 19 out of 40. So it's a much longer process, and I certainly wouldn't be expecting you to do that if there is a shorter way, but it is important that you do understand how that formula works. Okay, question 2. A card is drawn at random from a pack of 52 cards. A, find the probability that it is not a king, but also not a 5. So that is sounding like a compliment. If I'm saying not this and not that, if I can find the probability of a king or a 5, then not a king or not a 5 would be the complement of that, because these are the mutually exclusive events. There's not an overlap between kings and 5s, is there? Okay, so I could just easily subtract that away. So counting up in your head, because you know your deck of cards really, really well, there's 4 kings, there's 4 5s, which means there's 8 out of 52 are either a king or a 5. I'm not going to simplify that yet, I'll wait for my final answer. So that means the probability of neither a king or a 5, neither a king or a, well, let me write that again. Is going to be 1 minus 8 over 52, which simplifies down to be 11 out of 13. Part B, find the probability that it is an odd number, or black, or a picture card. Is that mutually exclusive, those events? No, there is an overlap. What would be the opposite of an odd number, a black, or a picture card?
A red number.
Yeah?
And 1 through 10.
So probability of odd, black, or picture is going to be equal to 1 minus, the opposite of that would be even, red, and not a picture. Okay, and that might be easier to work out, because then I don't have to worry about which ones I'm counting twice. I just don't want any even, any red, and no pictures. Okay, so how many red cards, how many cards are even and red?
10.
10. So there's the 2, 4, 6, 8, 10. There's 5 cards in the suit, but there's 2 suits that are red. Okay, so there's 10 cards. And I obviously don't have to count the picture cards, because it says not a picture card. Okay, so there is 10 cards that are even red and not a picture. So if I subtract that away, that means that there is 21 out of 26 odd black or picture cards. Okay, 12D.
Or we thought it was possible.